Welcome back to the deep dive. We've got a stack of research today that I think is going to fundamentally change how you look at the headlines.
Yeah, it really reframes the whole conversation.
Because, you know, we spend a lot of time on this show talking about intelligence when it comes to AI.
Yeah.
Like, is it smarter than a fifth grader?
Right, or can it pass the bar exam or beat a grandmaster at chess?
Exactly. But the research we are unpacking today, specifically this really dense, fascinating paper from the team at METR.
That stands for Model Evaluation and Threat Research, by the way.
Right, METR. They argue that we are measuring the wrong thing entirely, or at least we're using a totally outdated ruler.
We are.
They're suggesting that the difference between a toy and a tool isn't about IQ anymore. It's about time.
That is the core shift right there. It's moving from measuring difficulty to measuring endurance. Because if you look at the current state of AI, we actually have a huge problem with the old benchmarks.
You mean things like the MMLU or the GLUE tests? The ones where we see those constant 99% accuracy headlines?
Exactly those. The problem is saturation. These modern models are becoming so capable that they're effectively acing the tests across the board.
So it's hard to tell them apart.
Right. It's like giving a basic calculus exam to a room full of math professors.
Everyone gets 100%.
Exactly. You can't tell who the brilliant, once-in-a-generation visionary is and who's just a really competent professor because the test itself has a ceiling.
The test is just too easy for the class.
Right. So METR is proposing a totally new metric. They call it the 50% task completion time horizon.
Which is, I mean, that's a bit of a mouthful.
It is a bit academic.
50% task completion time horizon. Let's break that down for everyone before we get into the really scary numbers. What are we actually measuring here?
It's much simpler than it sounds. Instead of giving the AI a puzzle and asking, can you solve this, you give it a real task and ask, how long would it take a human expert to do this?
Okay.
And specifically, what is the longest duration of work where the AI can still succeed at least 50% of the time?
So it's really about reliability over a span of time.
Precisely. If an AI has a time horizon of, say, 10 minutes, it means it can reliably, half the time, complete a task that takes a human 10 minutes.
And if you give it a task that takes a human 20 minutes,
the AI likely crashes or gets distracted or hallucinate before it finishes. It just can't hold the thread that long.
I like this a lot because it feels so much closer to how we actually evaluate people in the real workplace.
Oh, absolutely.
Like when you hire a brand new intern, you don't give them a 6-month project on day one.
You'd never do that.
You give them the task that takes 5 minutes, go get coffee,
yeah,
file this document, update this one specific spreadsheet cell.
Right. You measure their agency by how long they can go without needing you to step in and fix things.
Exactly.
You trust a senior manager with a 6-month horizon. You trust a fresh grad with maybe a 1-day horizon. And what this research did was trace that exact time horizon for AI models from 2019 all the way through to 2025.
And looking at this chart they provided, the slope of this line is not gentle.
No, it's not.
It's basically vertical.
It's exponential rocket ship.
Let's walk through the history here, because I think it puts things in perspective for the listener.
Yeah.
We start in 2019, the ancient history of AI.
At dark ages.
Right. We're talking GPT-2.
Mm-hmm.
Do you remember using GPT-2?
I do. It was charming.
Charming is a very generous word.
Yeah.
It was the one that could write a weird story about unicorns if you got really lucky, but if you asked to do anything real, it just fell apart.
Completely. And according to this study, GPT-2's time horizon was measured in seconds.
Literally, seconds.
Literally. It could complete a sentence, maybe a very short prompt. But if you asked it to hold a context for more than a few seconds, like read this paragraph and summarize it, it would completely lose the thread.
It would just start repeating itself or making things up.
Basically, yeah. It had zero agency. It couldn't plan. It just reacted to the immediate previous word.
So it had the attention span of a goldfish.
Pretty much. Then we moved to the GPT-3 era, the Da Vinci models.
This is where people actually started paying attention.
Right. It was a big step up in language fluency, sure. But in terms of this time horizon metric, we're still looking at tasks that take a human less than a minute.
Okay, so it could write a focused email.
It could write an email. It could answer a specific trivia question. But if you asked it to, say, plan a travel itinerary, check the flight prices, and draft an email to my boss about the dates.
It couldn't chain those actions together.
Exactly. It would fail before the minute was up.
So we are still in the seconds to maybe a minute range there. Then comes the explosion, GPT-4, and models like Claude 3 Opus.
This is where we break into the 5 to 30-minute range, and this is significant because we enter the realm of what the researchers call HCAST tasks.
HCAST, what's that stand for?
Human-calibrated autonomy software tasks. These
Okay.
aren't toy problems anymore. These are things like configure this software package or set up this server environment or debug this specific function in a Python script.
Real, actual billable work.
Exactly. The kind of thing you'd pay a freelancer to do. Models like the original GPT-4 could handle tasks that take a human maybe 5 or 10 minutes.
But the paper focuses heavily on the current frontier. The models that just dropped or are dropping right now, like OpenAI's o1 and Anthropic's Claude 3.7 Sonnet. What is the number for those?
This is a headline stat for me. Claude 3.7 Sonnet has a 50% time horizon of roughly 59 minutes.
An hour.
Roughly an hour. That means it can reliably half the time automate a task that takes a skilled human expert a full hour of concentrated work to complete.
Just pause on that for a second.
Yeah.
Think about that. In roughly 5 years, we went from can't finish a sentence without forgetting the subject to can do an hour of autonomous engineering work.
It is an exponential curve. The study actually calculated the doubling rate. You know Moore's law, right? Where computing power doubles every 2 years.
Sure, everyone knows Moore's law.
Well, this autonomy horizon, the length of time an AI can work without help, is doubling approximately every 7 months.
Every 7 months.
Specifically, every 212 days.
That means if it can do a 1-hour task today, by the time I need to buy a new calendar, the AI could potentially be handling a 2-hour task.
That is exactly the trend line. And to use your analogy from earlier about the intern versus the manager, we've basically watched a toddler grow into a competent junior analyst in the span of 5 years.
That is blistering speed. But I want to dig into the how of this, because a lot of listeners might be thinking, well, computers just get faster, right? Is this just because we threw more GPUs at the problem, or is the AI actually thinking differently?
It is definitely not just raw processing speed. Think about it. If you give a distracted person a faster computer, they're just going to get distracted faster.
Right.
This is about qualitative improvements in how the models actually operate.
Yeah.
The researchers identified a few key drivers, but the biggest one, the one that really extends that time horizon, is self-correction.
Okay, let's unpack that.
Yeah.
Because my experience with older models was that they had zero ability to self-correct.
Right.
Like if I asked it to write code and the code gave an error, what happened? It would just apologize.
I apologize for the confusion.
Yes. And they would spit out the exact same broken code again.
Exactly. The loop of death. It would panic. It didn't know how to step back. It would just try to force the square peg into the round hole over and over until you just gave up.
But the newer models are different.
Very different. Models like o1, they have this reasoning capability. The paper mentions a specific example that highlights this perfectly. A model tried to use a command called it's a command line text editor to modify a file.
Classic IT stuff.
Right. And it messed it up. The command failed and actually corrupted the file slightly. Now, an old model would have just kept trying to run the command or given up completely.
But what did the new model do?
The new model saw the error, realized why the said command failed, and made a strategic decision. It essentially said to itself, okay, patching this is too risky. I'm going to rewrite the file from scratch to ensure integrity.
That's actually problem solving. That's real resilience.
It is. It's the ability to recover from a stumble, and that is what extends the time horizon. If you trip 10 minutes into a task, but you can get back up and dust yourself off, you can keep going for another 50 minutes.
But if you trip and just lie there, your time horizon ends at 10 minutes.
Exactly. So better reasoning leads to better recovery. Plus, they have much better tool use now. They are just better at using bash terminals and Python scripts without making basic syntax errors.
So they are making fewer unforced errors to begin with.
Exactly.
Okay, so they are getting smarter, they're more resilient, they're better with tools. And you knew there was but coming here, this research was done by METR, using their specific benchmarks.
Right. SWAWE. HCGST rebench.
For context, SWAIA is software atomic actions, taking under a minute. HCST is up to 30 hours, and a rebench is heavy machine learning tasks taking around 8 hours. But these are all lab conditions.
Yes, they are.
And anyone who has worked a real job knows that lab conditions are not real life. Real life is messy. My boss gives me instructions that make absolutely no sense.
Oh, constantly.
The documentation I need hasn't been updated since 2015. Or the guy who wrote the code left the company 3 years ago and didn't leave any notes.
The messiness of reality.
Exactly.
Yeah.
Did the researchers account for the fact that the real world isn't a clean multiple choice test?
They actually did, and I found this part fascinating because they actively tried to quantify messiness. They identified 16 specific messiness factors that make real work hard.
What counts as messy to an AI?
Things like unclear feedback loops. In a benchmark test, you usually know immediately correct or incorrect. In the real world, you might write a report and not hear back for 3 weeks.
Or you deploy code and it looks fine, but it causes a memory leak 3 days later.
Exactly. The AI doesn't get that instant dopamine hit of, I did it right. It has to operate in the dark. Another huge factor they looked at is information seeking.
Which means what exactly?
It means the answer isn't in the prompt. You have to go proactively find it. You have to read the documentation. You have to Google it. You have to search through the company wiki to find the one page that explains how the server is set up.
To be fair, humans are pretty bad at that too. Read the manual is the advice nobody follows.
That's very true. And it turns out AIs struggle with it significantly as well. They tested this. They gave the models messy tasks and clean tasks. And unsurprisingly, the performance dropped on the messy ones.
Can you give us a concrete example of a failure there?
Yeah, there was a capture the flag cybersecurity task. The model needed to open a file to get a clue, but the file had a weird encoding. Now, a human hacker would look at that and say, that looks like base 64, and they'd check the encoding first.
Investigate before acting.
Right. But the AI, it just guessed. It tried to open it with standard encoding, failed, tried another guess, failed. It wasted a ton of time and tokens because it lacked that instinct to investigate first.
So messiness is the kryptonite. It breaks the streak.
Well, it slows them down. And this is the part that I had to read twice to believe the researchers found that the rate of improvement is identical.
Wait, really?
Identical. Yes. Even though the messy tasks are harder, the models are improving on them at the exact same exponential rate, that 7-month doubling time. It applies to the messy tasks just as much as the clean tasks.
So the trend lines on the graph are parallel.
Perfectly parallel. The messy line is lower, absolutely. It's a harder test, but it's rising just as fast. So messiness delays the AI, but it doesn't stop the exponential growth. It's just a higher hurdle. But the AI is jumping higher every few months.
That is incredibly sobering. You'd think the ambiguity of the real world would be a hard ceiling, like a wall they just couldn't get past because they lack human common sense.
Right.
But you're saying it's just a speed bump.
It seems to be literally just a speed bump. And to prove this wasn't just METR grading their own homework, they looked for external validity. They applied this time horizon methodology to the industry standard for software engineering, which is called SWE Bench Verified.
And how did the numbers look outside their own lab?
Even scarier, honestly. On SW Bench Verified, the trend wasn't doubling every 7 months, it was doubling every 70 days.
70 days, that's barely 2.5 months.
Correct. Now, we have to be totally fair here. There are some caveats about how SWE Bench estimates human time. It might be a bit loose,
Right.
but even if it's off by a wide margin, the directional trend is undeniable. It is blisteringly fast.
And there's a huge economic kicker here too, isn't there? Because speed is one thing, but businesses care about the bottom line.
Oh, absolutely. They compared the cost of the AI, so that's computing power, API tokens, electricity, to the cost of a human engineer doing the exact same task. They based the human rate on a Google L4 software engineer's salary.
Which is substantial.
Very substantial.
Yeah.
And for the successful runs, the AI cost was often less than 10% of the human cost.
So 10% of the cost.
Uh.
And doubling in capability every few months.
Yeah.
If I'm a CFO listening to this on my drive to work, I'm seeing dollar signs. I'm thinking, great, let's fire the engineers and hire the bots. But if I'm an engineering manager, I'm seeing a massive problem.
Right.
Because cheap and fast is great, but if it breaks the code base because it doesn't understand the system, it's totally worthless.
And that brings us to the maintainer gap. I'm really glad you pivoted there because this answers the question that everyone always asks, which is, why hasn't AI taken my job yet if it's so good?
Right. Break down this maintainer gap for us. What is it?
So they set up an experiment involving internal PRs, pull requests. This is fixing bugs in a company's own internal code.
Right.
This is very distinct from writing a new app from scratch. This is go into this massive dusty code base that we've been building for 10 years and fix that one weird bug in the billing module.
Honestly, it's the hardest kind of work. The kind where you need to know why the code was written that way 5 years ago by someone who doesn't work there anymore.
Exactly. So they compared a maintainer, a human who works there, knows the code, knows the history against a contractor. Essentially a skilled human outsider who is a great coder but has zero context on this specific project.
And then they compared the AI to both of those human baselines.
Yes.
And what happened?
The maintainer fixed the bug in roughly 5 minutes. Boom, done. They knew exactly where to look. They said, oh, that's Dave's code. I know that function. Here's the fix.
And the contractor, the outsider.
81 minutes.
Wow. That is a massive difference. 5 minutes versus an hour and a half, just because of context.
Context is everything in real work. Knowing where the files are, knowing the history of the decisions, and here's the kicker. The AI performed almost exactly like the contractor.
So the AI currently looks like a really smart freelancer who just walked in the door and has no idea where the bathroom is?
That's exactly it. It lacks institutional memory. It can do the work eventually. It has the raw coding skill, but it has to hunt and peck and figure things out that an actual employee just naturally knows.
That explains so much about what we see in the enterprise today. It explains why AI is amazing at write a Python script to sort these images, which is a totally isolated task, but struggles massively with refactor our legacy billing system.
Right. It doesn't know your billing system. It has to learn it from scratch every single time, like a contractor on day one.
But, and this is scary, but contractors eventually learn the system, don't they?
They do. And as context windows get bigger, Google just released a model with a 10 million token context window that gap might close. You could theoretically feed it the entire history of the company. But for now, that maintainer gap is the moat protecting human workers.
For now.
Yeah.
Let's play the extrapolation game. That's the real mission of this deep dive. If we're at roughly 1 hour of autonomy now, and we are doubling every 7 months, where does this end?
The researchers put a flag in the ground at the 1-month threshold.
Meaning an AI that can work autonomously for a solid month.
Correct. Specifically, they defined it as 167 working hours. That's basically 1 month of full-time human work.
So I give it a prompt on the first of the month. I say, build this application, market it, and set up the customer support. And it comes back on the 30th with the finished product.
That's the idea. It navigates the problems, it fixes its own errors, reads the docs, spins up servers, handles all the messy hiccups, and doesn't crash once in that whole month.
When? When do they predict we hit that line?
Based on the 2019 to 2025 trend, if that line keeps going up, and we have to say trends can break, we could hit a wall.
Sure.
But if it holds, we hit that threshold between late 2028 and early 2031.
That is really soon. That is 3 to 6 years away. That is well within the planning cycle of almost every major company operating today.
It is. And think about what that shift actually means. You stop assigning tasks and you start assigning projects. You aren't using AI as a tool anymore. You are using it as a department.
It fundamentally changes the organizational chart. You go from, I need an AI to write this email, to, I need an AI to run this entire marketing campaign.
Or I need an AI to build the product from scratch.
But you mentioned trends hitting a wall. Is there a scenario where this slows down?
Absolutely. The sensitivity analysis in the paper covers this in depth. Maybe we run out of high-quality training data. Maybe we hit a hard limit on power consumption because these things are massive energy hogs. Or maybe the underlying algorithms just plateau.
But there's also a scenario where it speeds up, right?
Yes, there is. Agency training. Right now, most models are still fundamentally trained to predict the next word, but labs are starting to train models specifically to be agents.
To specifically learn how to plan for the long term.
Exactly. If that works, that 7-month doubling rate could actually accelerate.
So 2028 is just the business as usual estimate.
It's the current trend holds estimate. It could be slower, but it could definitely be faster.
Okay, my brain is spinning a little bit. We've covered a lot of ground today. From the goldfish memory of GPT-2 in 2019 to the hour-long engineer of 2025.
To the potentially month-long project manager in 2028.
So for the listener driving home right now or working out, what is the one thing they really need to take away from this? What is the core so what?
The takeaway is that the metric has completely changed. Stop looking at IQ scores. Stop looking at whether it can pass a standardized test. Start asking, how long can this thing run?
Right.
That is the new measure of reliability. It doesn't matter if the AI knows the answer, if it gets distracted or hallucinates 10 minutes into the job. The time horizon is the ultimate measure of trust.
And if you are building workflows today in your business,
don't build for the tools of today. If you're building workflows that assume AI needs you to hold its hand every single step of the way, you might be building for the past. You need to start thinking, what happens when the tool can run for a week without me?
it's the difference between buying a power drill and hiring a master carpenter.
That is the perfect analogy. You need to prepare your business for the carpenter.
Before we wrap up, I want to leave everyone with a thought from the very end of the paper. It was a bit of a philosophical bomb drop that the researchers just tucked into the conclusion.
Ah, the AGI point.
The AGI point.
Yeah, this is the one that keeps me up at night. The study notes that a true artificial general intelligence and AGI would theoretically have an infinite time horizon relative to human tasks.
Infinite.
Right. It would effectively never need a human to bail it out for standard work. It could run forever.
So if we are at 1 hour right now, and we double every 7 months, 1 hour, 2 hours, 4, 8, 16, how many doublings are we away from forever?
It's fewer than you think. To go from 1 hour to a full year of autonomous work, it's only about 13 or 14 doublings.
And at a 7-month rate,
Less than a decade.
less than a decade to go from smart intern to doesn't need us anymore. That is definitely something to mull over on your commute. Thanks for joining us on The Deep Dive. We'll see you next time.